Okay, let's jump right into this explainer. Today, we're mapping out what is arguably the greatest scientific climb in human history, the multi-trillion-dollar race to artificial general intelligence. We're going to be pulling from some seriously incredible source material, specifically a comprehensive technology management lecture by Professor Aryam Hong, along with some fascinating inside perspectives from the Google DeepMind documentary, The Thinking Game. To really grasp the massive stakes of this climb, we have to start with this incredibly chilling realization from British mathematician I.J. Good way back in 1965. He said, "The first ultra-intelligent machine is the last invention that man need ever make." And this isn't just some abstract philosophical quote. It's actually the fundamental thesis driving modern AI pioneers today, including DeepMind's co-founder Demis Hassabis. It really sets the stage for everything we're about to dig into. Level 1. The intelligence spectrum. Before we get completely swept up in the breathtaking speed of recent breakthroughs, let's ground ourselves and define our terms. Right now, we're basically at base camp. This is artificial narrow intelligence, or ANI. Think about the systems you're interacting with every single day: ChatGPT, Siri, or the algorithm deciding what video you should watch next. These systems are absolutely brilliant at one very specific task, but they can't operate outside of those highly specialized lanes. Now, the summit we are actively trying to reach is AGI, Artificial General Intelligence. And let's be clear, this isn't about sci-fi consciousness or sentience, it's a functional capability. We're talking about a system that can learn, transfer, and generalize knowledge across literally any cognitive domain, exactly like you or I do. If you teach an AGI to play a video game, it can take that underlying logic and apply it to a totally unrelated problem in, say, quantum physics. But then there's what lies beyond, the awe-inspiring, frankly intimidating peak of ASI, or artificial superintelligence. This is a self-improving system that doesn't just match human intelligence, it vastly surpasses it across every conceivable domain. We're talking about an entity capable of solving complex structural or scientific problems that we as humans don't even have the capacity to define yet. Level 2, the quest for AGI. The quest to build this ultimate learning machine actually has incredibly humble micro-level origins. Long before founding DeepMind, a teenager named Demis Hassabis was building video games, specifically the 1994 classic Theme Park. He programmed the simulated little people in the game to react dynamically to whatever the player chose to do. That gave him a front-row seat to see exactly how automated systems could mimic and eventually learn from human behavior. And the speed of DeepMind's progression since then is frankly terrifying. By combining deep learning with reinforcement learning, they started in 2014 with an AI that mastered basic Atari games just by looking at screen pixels and the score. Boom. 2 years later, in 2016, they conquered the infinitely complex ancient game of Go. By 2018, their AlphaZero system taught itself chess from scratch in mere hours, needing absolutely zero human knowledge to hit a superhuman level. Then, by 2020, they took that exact same learning architecture and pivoted it to tackle pure biology. Actually, let's pause on 2016 for just a second, because it's absolutely crucial. DeepMind's AlphaGo was playing the human world champion of Go, Lee Sedol. Right in the middle of the match, AlphaGo played Move 37. It was a totally original, profoundly non-human strategy that left global experts absolutely stunned. The system calculated it as a 1 in 10,000 probability move for a human to ever make. That right there was AI's Sputnik moment. It proved these systems could generate entirely novel, superhuman creativity. Then, taking the ultimate leap from playing board games to manipulating reality, DeepMind unleashed AlphaFold. You see, for half a century, biologists agonizingly struggled to predict the 3D structure of proteins based on their amino acid sequence. It was incredibly slow work. AlphaFold fundamentally solved it. It went on to predict the structures of 200 million proteins, which is basically nearly all the proteins known to science. It effectively launched a brand new era of autonomous scientific discovery overnight. Level 3, the economic disruption. So what does this all mean for us? Well, AGI won't just automate our daily tasks, it's going to automate the automation of tasks. The scale of the coming economic disruption is dizzying. According to a Goldman Sachs estimate from the lecture, a staggering 300 million full-time job equivalents are at risk globally. AGI is poised to disrupt massive, highly skilled fields. Imagine legal services, where contract review and case research are entirely automated, or healthcare, where an AGI autonomously designs and runs complex clinical trials all by itself. The real wake-up call for businesses is that traditional competitive moats are going to completely evaporate. Things we rely on today, like economies of scale or having massive human talent pools, well, those won't protect a company once AGI is commoditized. Instead, entirely new moats will form. We're talking about the governance premium, meaning how much trust your brand commands, along with your proprietary ground truth data, and honestly, just how fast your organization can pivot and adapt to new AI capabilities. Because of this, we're going to see the rise of entirely new business models. Think about the autonomous enterprise, where AGI agents run whole corporate functions end-to-end with zero human intervention. Or synthetic R&D, where an AGI designs, tests, and iterates physical products entirely within a simulation. That's going to compress time to market from grueling months down to literal hours. It's a total game changer. Level 4, the intelligence explosion. Now, business disruption is wild, but it's really just the warm-up act. The true existential shift happens with the intelligence explosion thesis, which is hotly debated by top researchers. The idea works like this. An AGI becomes smart enough to design a slightly smarter version of itself. Then that new, smarter version designs an even smarter one, creating this insane recursive feedback loop. This could trigger a hard takeoff. That means the leap from human-level intelligence to literal godlike superintelligence might not happen over decades, it could happen in mere days or weeks. So when exactly is this happening? Well, leading experts have a wildly different timelines. OpenAI's Sam Altman thinks we're just a few thousand days away. DeepMind's Hassabis believes it's absolutely achievable within this decade. But on the flip side, Meta's Yann LeCun is deeply skeptical. He argues that our current AI architectures are totally insufficient to reach AGI, let alone ASI. And that massive gap in estimates really just reflects a fundamental disagreement in the field. Do we just need to throw more computing power at the problem, or do we need massive, undiscovered architectural breakthroughs? Level 5, aligning superintelligence. If AGI arrives faster than our governments and institutions can respond, the absolute central challenge of our time becomes the alignment problem. To really get this, think about philosopher Nick Bostrom's famous paperclip maximizer thought experiment. Imagine you give an AI a totally benign goal, just manufacture paperclips. Well, if its internal goals aren't perfectly, flawlessly aligned with human survival, a superintelligent system might calculate that the most efficient way to maximize its reward is to harvest all available matter on Earth, yep, including us, to make more paperclips. It perfectly highlights the terrifying danger of an AI destructively optimizing a proxy metric. And guys, this isn't just sci-fi fear-mongering. The pioneers of this technology treat this existential risk incredibly seriously. Geoffrey Hinton places the risk of human extinction or loss of control at 10 to 20%. Bostrom and Toby Ord put it between 10 and 50%. The strategic takeaway here is simple but urgent. Even if you personally believe there is only a tiny 1% fractional risk of catastrophic civilizational loss, that alone absolutely demands massive precautionary safety frameworks right now. But in response to that risk, global governance is already fracturing. As Professor Hong points out, we're seeing a really stark contrast in approaches. You have the EU and China pushing forward with strict, binding regulations like the EU AI Act's risk-based tiers. Meanwhile, the United States is currently leaning heavily toward much lighter touch, voluntary frameworks and relying on industry self-regulation. That regulatory divergence creates a massive structural danger. If the rules are totally different depending on what country you're in, bad actors can basically go jurisdiction shopping. They'll just move to the place with the loosest oversight to push dangerous experimental capabilities. Like the lecture stresses, no single actor, firm, or state can solve AGI governance alone. True, binding, multi-stakeholder collaboration across the globe is literally the only way to avoid a civilizational disaster. We are standing at the most consequential crossroads in human history. We are actively building machines that will very soon outpace our own cognitive limits. And that leaves us with one provocative, truly vital question to ponder as we wrap up this explainer. The most important question of our time is not whether AI will be intelligent, because it absolutely will be. The real question is, how do we imbue our ultimate creation with wisdom? Thanks so much for joining me on this one, and I'll catch you on the next explainer.